Alright, this topic is about simplifying radicals, and first I guess we should just talk about what radicals are. Radicals are square roots, and probably the way that you've seen them in the past are with numbers underneath that are perfect squares. So like square root of 25, or square root of 16, square root of 81, all of these numbers under the radical, the 25, the 16, and the 81, are called perfect squares. And they're called that because a number times itself gets you those numbers. So 5 times 5 is 25, 4 times 4 is 16, 9 times 9 is 81, etc. I would say, as a rule of thumb, if you're in 9th grade math or higher, you should know all of them from the square root of 1, excuse me, all the way up to the square root of 400. And conversely, you should know all of your perfect squares from 1 squared all the way up to 20 squared. They're good to know. They can save you some time. And if you have a task like simplifying radicals, you're going to need to know these numbers. So let's see. I guess I could... we'll just progress from there. What I would suggest having as a tool for this video, if you have it, or you can pause and make it yourself, is just start a list. 1 squared equals 2 squared equals, and it may feel a little ridiculous and redundant, but I honestly would suggest having you go through and making a list like this all the way down to 20 squared equals 400. And then also, before you continue the video, again, this may seem redundant, but I would also do the opposite, where you have the square root of 1 equals 1, the square root of 4 equals 2, the square root of 9 equals 3. It may feel like it's the exact same list as what I just told you to make, but honestly, having those tools at your fingertips can kind of help you, and besides the fact that writing them down twice kind of sinks them into your brain a little bit more, even perhaps subconsciously. So, alright, let's move up and... Or let me, whoops, sorry, I didn't mean to do that. How do I do this? Alright. Alright, let's continue. Now that we have an idea of what radicals are and perfect squares are, we need to talk about simplifying them. Simplifying radical means that we need to look at the number under the radical and see if any of its factors are perfect square, or is a perfect square. So let's take an example such as the square root of 40. We need to see if it's simplified. So the first step that we want to do is write down all the factors of the number. Write down all factors of the number. So put this in your notes. So the number that we're looking at is 40. We have 1 times 40. We have 2 times 20. 3 does not go into 40. 4 goes into 40. 4 times 10. 5 also goes into 40 8 times. 6 doesn't go into 40. 7 doesn't go into 40. 8 does, which we've already accounted for. So those are our factors of 40. What we want to do is look at these lists of 4, and we want to look for a perfect square bigger than 1. So that would be step 2. In your list of factors, look for a perfect square bigger than 1. Bigger than 1. Alright, so if we look at our list, we have 1 and 40. 1's a perfect square, but it's not bigger than 1, so we're going to just get rid of that. 2 and 20, neither one is a perfect square. 4 and 10, aha, 4 is a perfect square. If you have that list I mentioned, it's real easy to see them. So now that we have our list, we found the perfect square, we're going to use this pair, and we're going to rewrite square root of 40 as, we're going to give each of these numbers a house. Square root of 4 times the square root of 10. I like calling it, give it a house. So give each number a house, if that helps. Now, if we look at it like that, the square root of 4 times the square root of 10, remember that other list I suggested you make? Well, what do you know? Square root of 4 can be rewritten as 2. So this final answer becomes the 2 times the square root of 10. How do we know that we're done with this situation? Well, if we look at 10, which is still under the radical, and we write down the factors of 10, 1 and 10, 2 and 5, that's it. Are any of these perfect squares bigger than 1? No. So we are done. We have a final answer. Square root of 40 equals 2 root 10. So let me just add to our notes. We have write down all the factors of the number. In your list of factors, look for a perfect square bigger than 1. Step 3, give each number a house. Now you want to give each number a house and then simplify the perfect square. Simplify the perfect square radical. So that's what we did in our last step. 2 times the square root of 10. We had square root of 4 times the square root of 10. We simplified the square root of 4. Let's try another example. Let's say that we have square root of 18. So if we start step 1, we want to write down all the factors of 18. 1 times 18, 2 times 9, 3 times 6. Having a multiplication chart available if you're not super great on your multiplication charts or your multiplication facts definitely helps. Step 2, we're looking for a perfect square bigger than 1. Haha, 9 is a perfect square. So we give them each a house. And then if we have our other chart or we know our perfect square radicals really well, we know that the square root of 9 is 3. So this becomes 3 times the square root of 2. We're all done because the 2 underneath the radical, the only factors are 2 and 1, and there's no perfect square bigger than 1 there. Let's try another example. Let's try the square root of, let's say, 48. All right, 48, 1 and 48 obviously. 2 goes into 48 24 times. 4 and 12 jumps to mind. 5, no. 6 times 8 jumps to mind. No, 9. All right, so let's say that we have this list. There is actually another set of factors, but I'm going to hold off on it right now because it's not one that we know. Well, I don't know. My times table is up to that high. So we're just going to go with this. Looking for a perfect square bigger than 1. No help with 2 and 24. No help with 6 and 8. But look at that. Beautiful. So we give them each a house. Square root of 4 times the square root of 12. The square root of 4 is the same exact thing as 2 times the square root of 12. And we want to double check that we're done. The 12 has factors of 1 and 12. No big deal there. 2 and 6. Still no perfect squares. But 12 also has factor of 3 and 4. So we need to go a little bit further. I'm going to scoot this up a little bit. Alright, so 3 and 4, we're going to rewrite. Bringing the 2 down. 2 square root of 12 becomes 2, and I'm rewriting the 12 as 4 times 3. Now all the way across, this is multiplication, so just keep that in mind. Because what's going to happen now is this 4 is going to turn into a 2 also, because the square root of 4 is 2. So now we have 2 from here, times from here another 2, times the square root of 3. Now we just need to clean it up. What's 2 times 2? That is going to be 4 times the square root of 3. So sometimes when you go to simplify a radical, it's not clean, it's not perfect, we overlook factors, and it becomes a two-step process, and that's absolutely okay as long as you remember that it's all multiplication. What factor that we noticed, or I purposely omitted at the beginning of this problem, was 3 times 16. If we had our multiplication chart and it went up to 16, or we knew our 16 tables really well, we could have just done this in one quick step. We would have had 16 and 3 each in a house. Square root of 16 is 4. Bam, you're done. But if you don't know all your factors, you're still going to get the same answer as long as you're double checking. Alright, let's try a couple more. Alright, let's try, let's say that we have the square root of, how about 98? Whip out your multiplication chart or whatever you need to do. Let's start with 1 times 98, which we now kind of know is useless to even say because we're not going to use it. 2 goes into 98. If we divide 98 by 2, we're going to get a glorious number of 49. Now I'm going to stop here. I'm not going to look for any more factors because when I divided 98 by 2, I got 49. I am instantly recognizing this as a perfect square. And if I use, my brain is also thinking like, hey, if I use this pair, I'm only going to have a 2 left over in the radical, and I know that I can't simplify 2. So if you can recognize that, and the more you practice these, honestly, the more you will recognize them, the quicker they're going to go, and you're not going to have to like drown in a list of 80 million factors for numbers. All right, let's try one more. Again, if you want to give this a whirl, hit the pause button. Try it yourself. That's absolutely fine. 500. Let's list some of the factors. I am thinking 10 times 50 right away. And then because it's a 500, I know it's going to be 100 times something. And again, I'm going to stop. Because I have that list nearby that has my list of perfect squares, I'm noticing that 100 is a perfect square. 10 times 10 gives me 100. So I'm going to give each of those guys a house. What's the square root of 100? It's 10. The only factors of 5 is 5 and 1, so I know that I cannot go any further with it, and I'm all done. Alright, well I hope this helped a little bit. It's one of those rules that you can't leave a square root factor underneath a radical. It's a big no-no, so this is one of the first main rules of radicals, and if you want to find out the next main rule of radicals, go look at the video that's called Rationalizing Radicals. Thanks.